And if you look me up on QRCode.com, you'll see my address changing in the next couple of weeks. A good way to find out about band conditions is to go to dxheat.com and bring up the DX cluster. And there's lots of filters in the cluster. There's a few that I usually do. I take out W3LPL, which is an automated thing. I'm looking for what guys are hearing on the band. Also, you can uncheck other in case there's some call signs on there that aren't part of DXCC. You can pick phone only, CW, or digital. I'm going to pick phone, and I want to go to 20 meters and select only for that. So now I've got 20 meter only phone band. Now, the DX that I want to see is Europe, South America, Asia, Africa, but I don't care about North America. So I'm going to uncheck North America. So that'll give me all the other regions on the planet. And now there's a listing of stations that are being heard, and the source for those, I want to pick North America. So I'm going to have North America only as the source of the DX post. So guys in North America that are posting DX in other parts of the world outside of the continent will appear on this list. In the first look, it looks pretty busy. The time I'm recording this, it's 0745. In other words, it's 0045 local time. And the bands are, for us here in North America, pretty much dead. Let's see what was being heard earlier in the day. Here's VU2. That's India. That was heard in New Jersey 5x9 by W2MSA at 0100. And below that is 4S7. That's great. Yeah, off the coast of Africa for sure. And so over on this column is the guy who's heard the DX and put it up on the cluster. Then in the middle is the frequency and the call sign of the DX station. Here's a couple of guys from the West Coast, and they heard, I think that's Torgare, yeah, LA4UOA, who's well-known DXer and often has a very potent signal. So he was 5.9 in California. Not sure if that's northern or southern, but we can figure that out. Further down, there's a guy in France, and I see guys, you'll see the same call signs often posting DX. Some guys are real good about doing that. And if you don't know what a particular country is, you can click on the flag or the call sign, and it will bring up that information. So that's 65. Let's widen out this because there's a lot on here. Let's go to 100. And there's my friend Rick. He's posted MD0, 5.7 on the West Coast. And here's KN2T, who's a good listener. He tunes the bands a lot, so you'll find him posting a lot of DX. So as I go down the list and look at the time in between the postings, oftentimes there's just a minute in between. So there was a lot of DX on yesterday or the day before at around 2000 Zulu, which would be my local time. It's 7 hours different, so about 1 p.m. There's a Malta 9H1 Tango Tango, another very active DXer. Scrolling down here, just looking to see who's on the list. Because right now I don't have any antennas up as we're moving. There's, again, KN2T has posted a station in Turkey. And there's Giannis, S51DX. Giannis and his brother are really nice guys. If you have a chance to work them, do that. So it looks to me like conditions are pretty good. So here's the question. If one friend is saying, and by the way, the first guy has a 3-element monoband Yagi on the top of a hill. The second guy, as you saw, has a wire antenna. The guy with the wire antenna is working DX. The guy with the 3-element Yagi is not. And the reason for that is it's timing and when you're listening. And the way to find out when to listen and when to look for DX is to look at the cluster. Here I'm checking out CW, and again, great call signs, lots of good DX on here, anywhere from Cyprus to Japan, all over Europe, Asiatic Russia, Spain. There's really Lithuania. There's some great DX on here. So, as I said, if you come across a call sign that you're not familiar with, and here's a really rare one, you can click on it. It'll take you either to their website or to their information on QRZ.com, as you saw mine earlier, or it can take you to their website, which has, in this particular case, OJ0. That's one that's worth looking at. That's Market Reef, started by Marty and friends way back when, 1960 something. And if you haven't seen their antenna system, it is absolutely amazing. They have one of the biggest antennas in the world, and they have, I believe they have that set up now for remote control. So here's one of the rarest spots on the planet, and they have monster antennas. Guys in Finland are amazing. Okay, it's now 1 o'clock on the following day, and as you saw, there was a lot of DX on the West Coast at that time. So let's see if that's the case today. So we'll go back to the DX cluster. So it's dxheat.com. Open it up. Again, the cluster is a listing. And we'll go to 20 meters. And just quickly, 20 meters, DX, don't want North America, DX from North America. Okay, here we go. There was some stuff last night at 0300. That's to be expected, especially on the West Coast. All right, let's go on up in time here. Now, there's a bunch of information in the cluster, and I'm just touching on a few things. For example, it says band activity, North America. There's a big red dot on 20 meters. And it sort of goes down to 30 and up to 17. So you can see that if you're going to pick a band based upon what's on the cluster, 20 meters is really hot. So let's take a look and see what that's about. And I see some familiar call signs. Here's Slavko, S57DX. He and his brother Janis, S51DX. Super nice guys, incredible operators. They're just a lot of fun to talk to. Here's another one, G4AKC, often pedestrian mobile, terrific operator with a very simple antenna. Mobile gets out great. I don't know if he's, oh yeah, it says here bike, mobile, Mobley, on 14191. Hawaii, again, Slavko's posted, Lebanon. Again, G4AKC, G4 American Kennel Club, Hawaii, Greece. Again, if you're not sure what country, you can click on the flag, and it says Brazil. Click on the flag, it says Hawaii, and so on. Here's Lauro, IK4GR, another terrific operator, really good, posted by K2TRD, who does post a lot of DX. If you haven't subscribed, please do so. If you have any questions, post them below. There are other clusters. If there's one that you like better or has some more information, list that so we can all go take a look at it. Thanks for watching. I'm Jim, W6LG for Ham Radio Basics. See you the next time. Hi, this is Jim, W6LG for Ham Radio Basics. Welcome to the final broadcast from Wolf Mountain as we close escrow on the sale of this house today, and we'll close escrow on the house that we're purchasing in about 3 days. Right after this, I'll show you something I've been looking for 38 years. Stand by.
CQ calling, CQ low, CQ. Whiskey 6 Lima Golf, Whiskey 6 Lima Golf.
As I said, we closed escrow on the sale of this house, so things are being packed up, and as boxes and other stuff was retrieved from the attic, an old briefcase of mine was up there. We opened it up, and son of a gun, there was a QSL card from 1970. So here's a picture of that guy from the 1970s. In fact, this I think was in June of 1970. My contact with him was, I believe, in April 1970. He's got some visitors from the United States. You can see the Drake C line and the Shure 444, which at that time and even today is one of the best microphones ever. After that, that guy had a Drake 7 line. You can see he's got an L4B, T4, XB, R4B, MS4B, MN2000, and some other stuff. As I said, he really liked the Drake equipment. The envelope that arrived with the QSL card in it looked like this, and it was a you can figure out where they're from. And if you haven't figured it out already, the guy in the picture is, or was, the King of Jordan, JY1, and he was nice to everybody he talked to. He was the professional operator on the air. He was friends with people in other countries, even some that might surprise you. I think one of his closest friends was Amir for X-Ray 6 Tango Tango. And there's his QSL card, operator Hussein 1, QTH near Amman, with his P.O. box, which was famous to most hams, P.O. Box 1055. And here's the other side of the QSL card that shows when I made contact, the date of the, and there's, first of all, there's my call sign that was WB6JZC in the 1970s and late 1960s. Contact was made April 20th, 1970 at 1516 Zulu, and that's important. I'll explain why in just a second. Since megahertz was not in common usage, but megacycles was, it says 14 megacycles, two-way SSB. The King was good about giving signal reports. In fact, one that I got from him was 5x2. He was, like I said, he was the consummate ham radio operator and one of the best ones in the world. And at the bottom, he thanks me for the QSL card that I sent to him. And next to 73, it says, all best regards and wishes, Hussein 1. And so that's why I treasured that card. Back to the time on the QSL card at 1516 Zulu. At that time, on that location, I did not have a direct path to Amman. I worked the King long path, so I had my antenna pointed southwest. The King had his antenna pointed northeast, so he worked me the long way around the world. I worked him the long way around the world, and I was 5 and 5, and I don't recall what his signal report was. Usually he was quite strong, and he had a very distinctive voice. When you tuned across him, you knew right away that it was JY1. So anyway, that was one of my favorite QSL cards, and nice to remember the contact with the King from the 1970s. In the pile of QSL cards were some others, really neat ones. This is John, ON4UN, from 1967. I think John's been licensed since the 1950s. Neat guy, written lots and lots of books. Other QSL cards that were in that pile. One guy was really tough to work. That was Charlie Radio 5 Sierra Papa, CR5SB. He did not speak English. Here's a card from CR6AK from about the same time period. That's Angola. Here's another one from Angola, CR6EO. CR6 MK. And Gola still is tough to work, but again, those were long path contacts, long way around the world. From the same region, from Bahrain Island, MP4. Forrest Nelson, HC8FN on Galapagos Island. Best friends, and it's a truly nice guy. Always 6 MBG from 1975. Mike and Sissy were here just a couple of years ago. Here's a card from Dahomey, TY5. Here's a card from also Mozambique's Charlie Radio 7, and that's really it. Anyway, lots of fun working those guys, and again, it was mostly long path because I had no short path. Anyway, this is what happens when you finally empty out the attic after 38 years. I find the QSL card from King Hussein, JY1, and I will put that in a frame and stick it up on the wall of the new shack as part of building my new ham radio station, and I will chronicle that in a series of episodes about how I put things together, and if you're putting together a station, you may find some of it interesting. Anyway, thanks for watching. Sadly, 73 from Wolf Mountain, and the next broadcast I hope will be from Rockland, not too long from now. 73, thanks for watching. This is Jim, W6LG. If you have not subscribed, please do so, and hang in there. Give me time to get set up. We have to convert part of the garage to recording YouTube videos. 73, W6LG. Bye-bye. Hi, this is Ham Radio with Jim, W6LG, and I'm on Google Earth. I'm going to zoom into my new location, QTH. It's located in Rockland, California. The west side of the property borders a green space. And as we get closer to the house, you're going to see what I'm up against. So what do you think? We'll talk about that right after this.
CQ calling, CQ low, CQ. Whiskey 6 Lima Golf, Whiskey 6 Lima Golf.
Okay, so here's a new property. It's located at the beginning of a cul-de-sac. The rear property line is an embankment down, or the rear of the property is an embankment down to a drainage ditch and then up to a shopping center on the other side. I drew in Photoshop a diagram of the property and have superimposed it over the satellite photo. The rear property line is about 80 feet wide, so from the right and left sides there's about 80 feet. From the rear of the property, from the rear of the house to the rear property line is about 15 feet. So the area I have to work in is about 15 by 80. On each side, the property lines are about 100 feet long. At the front, at the beginning of the cul-de-sac, it's about 60 feet wide. I'm thinking about putting the M0ODZ tower in the middle of that space at the back, maybe up against the house. That would give me a maximum turning radius of about 15 feet. I think if I went over the fence line with an antenna, I don't know that the city would care. It's not an area that's easily gotten to. There is a walking path, but it's on the other side of the drainage ditch. A possible antenna in that situation would be a hex beam. Fairly small turning radius. They cover lots of bands. You probably know that. It can be 20 to 6 meters. They have a little bit of gain, a couple 3 dB, and some front to back. I don't think front to back is going to be a big issue in that location. They're relatively light, not real pretty. In fact, not pretty at all. But they're strong. They can take a lot of wind. The design is genius, and for what it is, they work reasonably well. So anyway, that's potential. That antenna in the picture there is maybe 25 pounds, easily turned with a light-duty rotator, and I've got several rotators that will handle that with ease. Another potential, I got an email from a good friend. He's put up in the Reno area these loops, and he's got 2 loops connected together. It's kind of a complicated system. I've built some loops in the past, not like this, not as good as this. They work, and they can work well. I worked a guy in Mozambique. His antenna was a loop, and that was on 20 meters short path in the afternoon. I'm going to blur the background just a bit so we can get a better idea of what the loop looks like. Not easily seen. In the middle down towards the bottom is a vacuum variable that rests up against the support mast. Vacuum variable is used, according to Jim, because the resistance of an air variable could be an issue. The impedance of this antenna, I believe, is incredibly low. A little bit of resistance here or there can eat up a lot of signal. So care is given as to how they're constructed, hence the copper tape that's wrapped around that unusual kind of PVC pipe that can be formed into a circle. So that's a possibility. They're very high Q, very small. Somebody looking at it really wouldn't know what it was or what it does. Good for probably 100 watts. And the performance would be interesting to try one of those and see how it compares. In the middle of that antenna is a vacuum variable like the one in this picture. In fact, that's the one I have, which is a Russian one from, I think it's 50 to 500 picofarads. Anyway, I've got a ton of tubing. We've moved all of the tubing from several antennas onto the property, so I'll be able to construct verticals. I could even make several Yagis. There's the remnants of 3 204 BAs, 3 4-element 20-meter Yagis, some tri-banders, and some other stuff. All right, that's it for now. Thanks for watching. If you have not subscribed, please do so. If you have a question, post it below. If you have an idea for an antenna that's worked well for you in a tight end and somewhat restricted antenna space, let me know and let the others know too. For now, this is Jim, 73. Thanks for watching. See you the next time. Bye-bye.
One of my YouTube viewers recently asked if it was possible to use the FFT function on an oscilloscope to measure the total harmonic distortion on a signal. And of course this is possible, so in today's video we're going to take a look at that. So let's start off with the definition here. The total harmonic distortion, or the fundamental total harmonic distortion, is defined as the total of the RMS voltages of all the harmonics divided by the RMS voltage of the fundamental itself. Now, of course, there's going to be some math involved when we're computing the THD from the FFT result, but we're going to use some shortcuts to help us out with that. The equation you typically see for computing total harmonic distortion is this. Now, what's going on in the top here is adding up the total RMS voltage of all the harmonics. When you add RMS voltages, the process is to square each voltage, add them all up, then take the square root of the sum. So that's what's going on here. So V2, V3, V4 represent the second, third, and fourth, etc. harmonics, and then we're squaring each of those terms, taking the square root, and then dividing by the RMS voltage of the fundamental. The FFT is going to show us the frequency domain content of the signal, both of the fundamental as well as all of the harmonic content. Now we can make measurements of absolute magnitude of each of these components, but more importantly, we can make relative measurements. When we talk about relative amplitudes, we're going to use a term called dBc, or decibels with respect to a carrier, or in our case it's really going to be dB with respect to the fundamental. This is graphically illustrated here. So let's say we look at the amplitude of our fundamental signal as here, and if we measure how far down, how many dB down the harmonic is, that becomes the dBc value for that harmonic. And by using the dBc values for each of the harmonics, this will give us a little bit of a shortcut in the math for computing the THD. If we take a closer look at the THD equation, again we've got our RMS sum of our harmonic RMS voltages divided by the RMS voltage of the fundamental. That could be expanded out to be the square root of the entire quantity of the second harmonic with respect to the fundamental, the third harmonic with respect to the fundamental. So you can do this all individually, v squared over v squared. Now let's also take a look at the DBC value. The DBC value, again, it's a logarithm of the power ratio. So DBC is 10 times the log of some power, okay, divided by the power of the carrier, or in our case the fundamental. If we take a look at that piece of it, it's a ratio of 2 powers. Power in this case is v squared over r, okay, whatever that voltage, RMS voltage is, squared divided by the load impedance. That applies in both cases. Now in both cases the load impedance is the same, so that cancels out. So that power ratio is equal to the ratio of the squared voltages. Well, that's exactly what we have here. So if all we could do is take these DBC values, okay, knowing that the DBC values, we can easily compute this power ratio. That power ratio is equal to these ratios. So we just need to compute that value and then sum them up and then take the square root. So we do that by taking 10 raised to the DBC value divided by 10. We do that for each of the DBC values that we have. We sum all of those up, take the square root of the sum, and then multiply by 100%. It's as simple as that. Now, of course, this computation you need a scientific calculator to do, but most people have that on their phones these days. So let's go take a look at it. So here's our test subject today. This is the auto leveling circuit that appeared in video 157 and 162 that takes an audio input that can vary over a very wide amplitude range and knocks it down to a more manageable, kind of a constant output. I put this together to go on the output of a radio scanner to avoid large variations in received signal strength. But I also made some comments in that video that while this works really well for audio, like for a scanner, it wouldn't work really well for high fidelity like music or television, because it does add some distortion. So now we can actually go measure that. So this is our DUT. I'm going to be inputting a 1 kilohertz signal from a signal generator that's got very low harmonic distortion, about 0.03%. That's at 1 volt peak to peak. Our output is going to be at about 50 millivolts peak to peak, at obviously the same frequency, but it's going to have some distortion on it, and that's what we're going to go measure. Okay, so here's the output of our circuit. If we zoom in on this, we can see that the signal isn't really a perfect sine wave. It's got a kind of a fatter lobe up here than it does down there, so we know it has some distortion in it. And we can actually see that in the FFT result. Okay, we can actually see here's our fundamental component here. We've got a second harmonic component that's right there, third, fourth, fifth, sixth, etc. So we know we've got some harmonic distortion to go measure. Now, just as a refresher, if you want to learn more about the FFT and using the FFT on a scope, you might want to check out my video number 65. And also, if you want to learn more about the use of dB and DBC and all these other dB terms, check out video number 136. Both of these videos, as well as the video for this circuit, will be linked down below, along with today's notes. So we'll simply use some cursors to measure these DBC values. So if I position cursor A right on top of the fundamental, right here, and it looks like I've got B already sitting on top of the second harmonic. Let's kind of reposition that back on the second harmonic here again, and we can see that's about 19.7 dB down. So we can record that value of the DBC value of minus 19.7. And if we keep working our way down through here, we go to the third harmonic and take a look at that one. And that one is about minus 35.5 or so. Call it minus 35.5 dB down. And let's move over to the fourth harmonic. This fourth harmonic is way down here. He's about minus 49.8. Let's call that minus 49.8. Now he's so much further down. He's close to 30 dB down from the the second harmonic, so it really isn't going to contribute much to THD. Once you get components that are more than 30 dB down, they're really going to kind of be in the noise. Okay, so let's take a look at the math here. We've got minus 19.7 dBc. We take 10 raised to that dBc value divided by 10, and we get 10.715, 10 to the minus 3. Compute the other ones here as well. Take the sum of those results, and we have 11.0073 times 10 to the minus 3. Take the square root of that, and we have 0.1049 multiplied by 100%, and we get a THD value of 10.49. So let's go validate that. Of course, now one way to validate that is to use the power application I've got on my scope here, which will compute the total harmonic distortion with respect to fundamental. And we can see I'm getting about 10.5, and I measured 10.49, so that's pretty darn close. And one last measure of validation is to use my Keithley 2015 THD multimeter, and that's also reporting 10.4, in some digits here, so 10.45 or so. So these all match to within about 0.1% or so. So we'd say that the FFT measurement on the oscilloscope gives us a pretty good result, as long as you set it up carefully. Now, one point that I'll make when using the oscilloscope here is to recognize that the scope most of them will use an 8-bit analog digital converter. And that's really going to limit the dynamic range of what you can measure. So if we're trying to measure something that's got a fair amount of distortion, like this audio device that I have here, where we're looking at about 10% THD, we can get some pretty good results. But if you're looking to try to characterize the THD of something that is well under 1% or 0.1%, you're likely not going to have enough resolution in the scope to give you repeatable and acceptable results. Because what you're likely will be measuring is the THD of the scope itself and not of your circuit. So if you need to measure THD of very low levels like that, then you're better off with something like a THD multimeter or a more precision analyzer that's designed specifically for measuring THD. Well, I hope you found today's short video interesting and useful, and you now know how to use the oscilloscope's FFT function to make some relative dBc measurements on a signal, and then be able to compute the total harmonic distortion from those measurements. As always, the links to the videos that I've mentioned during today's video will be linked down below, as well as a link to a PDF copy of my notes. If you like what you've seen, please give me a thumbs up. If you haven't subscribed already, please do so. And if you are a subscriber, be sure to click on the little bell that's down in the lower corner here so you can get an email notification each time I post a new video. Thanks again, as always, for watching, and we'll see you next time.
Hi, this is Ham Radio with Jim, W6LG, your YouTube Elmer for Ham Radio Basics. In getting ready for the big move, and it took months, 9 months, one of the things that was discussed was the number of coax connectors that I had strewn about the feed line in the backyard, and whether or not I incurred more loss than I realized. So as we packed up things, I gathered up the coax connectors and I put them together in a string. I'll see if I can pick this up. I'll be slightly out of focus, but there are roughly 50 coax connectors here. I've done the test before where I used a watt meter to measure the loss, and there wasn't much of anything. The Array Solutions AIM 4170. This will measure loss down to about 1/100th of a dB, so I can get a really good idea about whether or not these connectors are lossy. There's some that are really old, or maybe they're not. We'll find out more about these coax connectors right after this.
Whiskey 6 Lima, calling CQ low CQ. CQ calling CQ low CQ. Whiskey 6 Lima, go. Whiskey 6 Lima, go.
Okay, so let's look at these coax connectors. I'm set them on a table, point the camera down at them. I think what I'll do is measure the loss in increments of maybe a foot. And then if there's appears to be greater loss with a certain kind of connector, I may daisy chain a bunch of those together and see what happens. From prior experience, this doesn't incur much loss. I think I'll do it at 30 megahertz since I'm an HF guy, and see what it looks like. So next picture you should see will be the string on a white table, and then I'll do a screen capture of the AIM 4170 graphical analysis, and it prints out some data, and we'll pick that data up and use it to measure the loss in a string of coax connectors. And again, there's about 50 here. Okay, so here we go. I'm going to count down 20 coax connectors and then separate the first 20 from what looks like about 50 connectors. And then we'll do a measurement with the AIM and see what it says. And again, this is going to be at 30 megahertz. Be a very different answer at 2 meters, for example. All right, here's the graph, and the loss at 30 is about 0.05 dB, so virtually lossless. Okay, let's do the next 20 connectors, and I'll reattach the first 20 and then count up from there another 20 and see how far that goes. And again, these are mostly adapters, and most of them have been outside. So here it's drawing the graph again. This time the loss is about 0.12, so roughly double what it was for the first 20. So now we're at 40 coax connectors, and still that amounts to just a couple of percents. So let's count the remainder connectors and see how many that are left in the chain. Okay, I did a quick count. There are 55 connectors in total. So let's plot that and see what happens. Okay, and the answer is about 0.17 dB. Let's figure out how much 0.17 dB is, and we'll do that by going to a website and grabbing an online converter and see what that looks like. So here's the converter, minus 0.17 dB is less than 4%. So total loss in the system about 4%. And again, looking at this group of coax connectors, this was done at HF at 30 megahertz. 2 meters and 440, the losses would be quite a bit larger. It also assumes a low SWR. In the face of a high SWR, the answer again would be different. So there you have it. Old coax connectors, kind of tarnished, not so good looking, but the loss was virtually nothing. If you haven't subscribed, please do so. I'm Jim, W6LG for Ham Radio Basics. Thanks for watching. Hi, I'm Jim, W6LG, W6. Hi, I'm Jim, W6LG, your YouTube Elmer for Ham Radio Basics. Quick update. We did move from Wolf Mountain to Rockland, California. So from about a 6.5 acre site down to about a 6,000 square foot site. So from 300,000 square foot lot to about 6,000 square feet. And having phased arrays, phased Yagis is a thing of the past. However, I think I can do some neat stuff here. This is more typical of what ham would be facing in a residential area, and that's good. So I'll be able to experiment with antennas and show you what what works and what doesn't work. We'll talk more about that right after this break.
Whiskey 6 Lima, calling CQ, low CQ. CQ calling CQ, low CQ. Whiskey 6 Lima, go. Whiskey 6 Lima, go.
Okay, so we're here at the new house, and it's a big change. The house is smaller. The backyard is really tiny. From the back wall of the house to the fence line, which I believe to be the property line, is 15 feet. So in theory, I'd have a turning radius on an antenna of about 15 feet. However, behind the house is a kind of a wash. There's a channel in the very bottom of this kind of deep cut. And I don't think anybody walks on this side of the channel. It looks like there's a lot of walking that goes on a pathway even on the other side, but not this side. So I'm thinking I can encroach, go over the fence a bit with an antenna, we'll talk about that in subsequent episodes, but looking at things like loop antennas of various configurations, high Q loop. KP4MD suggested a loop around the property and sent me a diagram of what she'd recommend I do. And it looks like a great idea. There's one hex beam in the area, and that has a fairly tight turning radius. Antenna restrictions here are 30 feet max, which gives you a pretty high takeoff angle at 20 meters. So, and at 40 meters, really high. So 40-meter Yagis out of the question. 20-meter Yagis, yeah, it's going to be a bit iffy. Might start out with a dipole. Of the three towers, I did keep the rotating tubular tower, the M0ODZ. So I'd have to restrict its height to 30 feet to keep the city happy. And there are people on the street who work for the city. Anyway, and they've seen the license plate, so they figured out who I am, and some have already done some research on YouTube. In any case, it's sort of bad news, good news. The bad news is it's a really tiny lot. The good news is it's more typical of what the average guy has to deal with. And what are my solutions? And basically, I'm starting from square one. Going to be building the shack in the garage. It'll be a walled-off portion of the garage, partitioned off. With sound-resistant walls as best I can do, because the garage is really close to the sidewalk. And how do I get feed line from there to the backyard? How do I get electricity into the radio room? I'd like to have a 240-volt circuit for an amplifier. I kept all of the equipment. But probably some of it's going to have to be sold off. There's not going to be the room to put all the equipment into play that I did in the past. Anyway, it should be interesting. It's really starting all over again. The site has some interesting negatives. To the southwest, there is a slight hill. Southwest for me would be towards Australia, New Zealand. Looks like shooting down the wash is towards JA, Japan, Asia. Europe is through the house, literally through the structure, which, if you can believe this house has an intercom. I have no idea why. It was built in 1991. It's got an intercom. In checking the neighbors' houses at their front doors as I walked around, they all have intercoms, which is nothing more than a long wire antenna connected to an audio amplifier. So I don't know how many of those things are still on, but it could be a dilemma. Most folks around here don't have landlines anymore, so that's not a problem. Most everybody has DirecTV or something called Wave, or there is a cable TV in the ground. There is not fiber optics, it's copper wire, but there is, the fiber is relatively close, so the speeds are halfway decent. that's it for right now. I'm in the master bedroom. I've got basically like a door set up with a couple of file cabinets, and that's my countertop. There's no station at this point. The garage is almost ready for that, so I'm getting close. I'm hoping this weekend that I get some help and frame up a wall or two in the garage for the ham radio station. Anyway, thanks for watching. If you have not subscribed, please do so. We're at about 22,000 subscribers and really growing pretty quickly, even though I haven't done a lot of videos. And the reason for the lack of activity is just been too busy. But once things settle down, I plan to do a lot of videos. As I pack things, I set them aside for videos that I thought would be interesting. Anyway, stay tuned. See you the next time. I'm Jim, W6LG, or YouTube Elmer 73. Hi, this is Ham Radio with Jim, W6LG, or YouTube Elmer, talking about ham radio basics. And along those lines, I got an email from a subscriber with some very interesting points and a couple of questions. So right after this break, I'll read the email quickly, paraphrase part of it, and then let's talk about what might be going on, because he asked questions that I think a lot of us have had and kind of wondered about. So stay tuned. Be right back.
Whiskey 6 Lima calling CQ low CQ. CQ calling CQ low CQ. Whiskey 6 Lima Golf. Whiskey 6 Lima Golf.
Okay, so let's take a look at his email. It says, and I'm going to paraphrase, I'm in the process of putting up a 20-meter dipole in a sloper configuration. I have a 40-foot tower and have a multi-band off-center fed dipole currently mounted on it, on the tower. I have the sloper mounted perpendicular to the original antenna. I've been trying to tune it, this sloper, and have shortened it more than I expected, and the lowest SWR I get is 1.7 to 1. Suspect somehow it's coupling to the off-center fed dipole or the tower. Any thoughts? Also, in general, I've noticed that when I adjust my PALSTAR tuner for lowest SWR at low power, when I increase power, the SWR increases. So as he raises power levels, the SWR changes. There is probably an hour's worth of discussion in the questions that he asks, and I'll try to cover it in about 6 minutes. With respect to the SWR changing as you raise power level, I'm going to put up on the screen a portion of a PALSTAR antenna tuner that is the sensor for the watt meter. Paul built some great devices. I've met Paul several times over the years at shows. We were in adjacent booths at HRO one time. I don't have any of his products, but I know they're well built. The device he uses to sense the SWR is a coil, toroidal coil, and cable center conductor passes through it, and so there's a transformer wound around this wire, and it samples a little bit of voltage. There are two diodes. One for one direction forward, one for the other direction reflected. That varies a lot from the original SWR meters, which were often a metal rod in either a tube or might have had a channel around it, and that's how they picked up the forward and reflected voltage. The thing that's in common with PALSTAR's watt meter and the old watt meters is they all use pretty much the same diodes. I'm guessing because in the schematic it doesn't call out the particular diode, but it's likely something along the lines of a 1 in 34 or a 1 in 60, which conducted very low voltages like 1/3 of a volt or 7/10 of a volt. And here's one of the reasons why the SWR changes. Those diodes don't conduct in a linear fashion. So as you raise the voltage, the output of the diode changes. And it changes enough to make the SWR change. So even though the SWR is the same, the diode is conducting in a different way, and it appears different on the meter or the digital readout. Also, the transformer that's used to sample, as we discussed, used to be a rod, and now it's a transformer. That device also is not exactly linear through all of HF or HF to 6 meters. And so some other parts are added to it to try to smooth out its response. So you have the sampling device in the SWR meter or watt meter giving a different answer at different power levels and different frequencies. And that's typical, and it doesn't mean the SWR is changing, it means the meter is changing. Does it matter much in the scheme of things? Not really. He's talking about a sloper, and as far as I know, a sloper has an impedance greater than 50 ohms, somewhere higher than a dipole. So let's say 80, 90, 100 ohms, something in that neighborhood. If let's say it's 100 ohms, if you're feeding it with 50 ohm coax, the SWR is going to be about 2 to 1. Now, I'm not sure if he's saying he's using the antenna tuner, and the lowest he can tune it to is 1.7 to 1. Not sure what's going on there. It could be that the links now are so screwed up that one side is longer than the other, or they're both too short. And that's certainly possible. If you achieve a 1.7 to 1 SWR and everything else being equal, stop. Your feed line losses are not going to be that great. It's not worth trying to get it down to 1 to 1. And on a dipole, it's probably not going to be 1 to 1. He doesn't mention if he's got any kind of matching at the feed point. I suspect he does not. Another issue, let's say he's using 100 feet of RG8X, and I'll quickly put up a little math on the screen. Let's say at 20 meters, the loss in that cable at 100 feet is, just pick a number, 25%. If he's reading 1.7 to 1 SWR at the end of that coax, the SWR at the feed point is greater, and likely by about 25%, because you've got that 25% loss. So it may actually be 2.3 to 1, or 2.5 to 1, or some number like that. So, also, common mode choke. Did he install any kind of feed point choke? Every antenna you put up for HF should have ferrite beads at the feed point, or some method, some balun, some ferrite beads, coiled coax to stop common mode currents. Common mode currents on the coax could give him a faulty SWR reading, and I don't know how the tuner would react to current flowing on the shield. It's designed to deal with current flowing on the inside of the shield. Anyway, to answer his question, it is common for the SWR to change with frequency and power, because that's the way the diodes conduct. A 1.7 to 1 SWR is decent, and if you get there and everything else is fine, leave it that way. Is it coupling to the off-center fed antenna and the tower? It may be. Depends on how close it is. There could be some capacitive coupling. This is a reach, but there could be some capacitive coupling between the end of the dipole and the tower or the other antenna, to the point where it acts like a capacity hat. Now that is assuming a lot, but I suppose it's possible. Anyway, the guy's email was so interesting, and he raised some good points that I just had to take a break this morning as we're going to start construction on the radio room. With respect to the radio room, I think the first thing I'm going to hook up is the ground, and I've been puzzling with that, and I think I've got a solution that you haven't seen before. So stay tuned for that. I'll be doing some filming with a camcorder outside, and we'll go to the common grounding point for the system in the house and how I connect to that and where that goes. If you have not subscribed, please think about doing it. We're about 22,300 subscribers, and I've got a lot of what I hope will be interesting videos, especially about building a station on a small residential lot. Thanks for watching. I'm Jim, W6LG, now in Rockland, California, 73.
Hello, this is W1VLF, Paul, and on October 13th I took a ride to the Nutmeg Hamfest. Took some video during that Hamfest, and hopefully you guys can take a look at it and maybe see something you're interested in. There's an awful lot of vintage radios there. Sorry about the shaky camera work, but this is my first video in a very long time. Basically, it's just a stream of consciousness. So take a look and enjoy it. Thank you. It's a beautiful fall day in the neighborhood. We're heading off to the Nutmeg Hamfest. Just a quick look at the W1VLF tower installation. Let's take a closer look at the top. That's a 6-meter beam on the bottom. 16 elements on a log periodic, home brewed for the FM broadcast band, and 2 13-element Cushcraft vertical beams for FM 2 meters. So off we go to the Nutmeg Hamfest. A crisp 44 degrees on October 12th. Okay, so we have arrived. A little warmer here than it is at home. And I'm going to walk up through to the flea market and we'll take a look at some of the cars and license plates. KC1DX. Here's a nice installation. Trailer hitch mount. Very nicely done. Looks like it has a tilt over on it. Let's get a little closer. Beautiful. Beautiful. Stop the tape here and move on to some other locations. Here's a W1BIQ. Interesting. There's a gentleman a couple people who got a prize, early prize from the flea market. Here's an interesting license plate. KB1JDY. Thank you for your service. Okay, well, I guess I'm going to sign off from here and actually enter the flea market. If there's anything cool, I'll bring sure to show it to you. Taking a look at some of the tables. Radar engineer's receiver, microwave receiver. Interesting.
You know what that is? Forum starting at 9 o'clock in the Danbury room, and the meeting session registration is in the Fairfield room.
Boy, I don't remember terminal strips.
You guys have a lot
Tubes. Ooh, look at the tubes. Adapters. Here's Joe. We'll take a walk and look at some of these tables.
It's about 50-50 lately.
Yeah, I'm definitely thinking about 2 weeks.
Oh, that's interesting. Some rope and a
Because I can't do anything but listen.
fluorescent orange
I hear people talking and stuff, and I'm like,
leaded weight for throwing over trees, putting antennas up.
Same thing.
Wow, look at all these hardline connectors here. OPF. Geez, I just bought an 1 1/4 one online. Too bad. $5 each. Ooh. Greenfield tap and die. Is this a big caliper? Is it open? Oh, it's a tap set. Okay. Greenfield Tap and Die, Massachusetts. Greenfield, Mass. Huge, huge industrial center.
Most of it gone.
Most of it gone. Unfortunately, just like everything else, most of it gone.
The headquarters building is still there.
I understand they have a museum there, which I'd really like to go to sometime.
I didn't know that.
What is this, a 450? No, 570. Microphone stands. That's kind of cool. Oh, look at equalizer, more microphones. How are you, sir?
I'm just fine.
Great. Now we're at the Quicksilver radio booth. Somebody just leaned into me. Hi, Rob. How are you?
Good.
Oh, you never know who you're going to bounce into at these flea markets. Let's just take a look along the line here. Wow, microphone connectors by the score. Still at the Quicksilver booth here. Look at all that copper wire. Doesn't that copper wire look beautiful? Coax cables. And all sorts of sizes and shapes. Jumpers. Silver plated too. Very nice. All sorts of ground cables, braids. Look like they're pretty well done. Colored tapes. Bulk connectors. Ooh, look at that nice little adapter kit.
Yeah, that is nice.
Look at that. Adapt anything to anything.
Yeah, I know he passed. Yeah,
I didn't know until yesterday.
Oh, really? Yeah, a few weeks ago. Yeah, maybe a month ago.
August
Okay,
10th, they said.
back in a couple of minutes.
Yes, that's why it's so powerful.
Look at that, some sort of digital prototyping trainer board, night kit, mini lab. Comes in a nice little Pelican case. Curtis Keir.
Yeah, that's what it is.
Let's see, what's this guy? AF power meter. Field strength meter, SWR. Oh, little solar panel over here.
What a nice tiny.
Powering, I don't know what, but
Take it home and I gave it
1
to
amp
Bob.
of USB solar. Oh, boy, that's shiny. There we go. Bird watt meter. A SWAT professional flashlight. Green laser pointers, all sorts of stuff. Ooh, headlamps. That's kind of cool.
Orange and green.
What am I doing?
Interesting, very interesting. Well, you know what time it is. I don't know if you can see that or not. Take a walk over there. We're heading outside. It's cold. Hey Dave, how are you? How are you? Good? All right, do I really want to go out here? Last time it was windy as heck. It doesn't look bad. It's kind of blue as the color balance on the camera. Here we are, we're outside. Oh, this is where I really enjoy it, right here. Take a quick look around here. A couple of big tall antennas over there. And then we'll start looking at some of the individual tables. Ferrite snap-ons. Mix 43. More ferrites.
Alright, be right there.
Thing is about ferrites is you have to know what the mix is, so you use it at the proper frequency range. Oh, look at this SMA type terminator and a gigantic 25 to 1000 PUF 15 kV vacuum variable. That's nice. Oh, look at this terminator. Attenuator. So that means it has an input. Oh, where are we? An input and an output. Very nice. It's quite a long table here. All right, signing off. Be back. There's my friend Larry, where is he? There he is, WA1LGQ. WA1LGQ! There he is.
Hey, there he is. What the hell?
I'm coming over to see my buddy Larry. I'm gonna,
Oh, no.
all right.
I want to sign a model release.
Uh-oh. Are we on public property? No, we're not. All right. So I'm sorry, I don't know you.
I'm W1 EPG.
Oh, you're the EPG, Paul.
This is E-Paul.
Yep. And let me zoom in on this shit. There's a shady looking character right there.
Or better known as the new bike.
There's Pete, W1PT. And you all know Larry. You do not look, Larry's so intent on what he's doing over there. He's not even gonna look up. Look at his hat he's wearing. Oh, I gotta zoom in on it.
I'm giving you the opportunity to get it.
Oh, hell. Most of them. All right, guys, you know what this thing is? You've heard about it many, many times. This is the classic boat anchor. Cobra microphone, TVI filters.
That would leave anybody.
Look at this. More filters. Okay, we're back. Not much to see here, but a lot of tar. But we go over here. Look at this. Look at this. The civil defense Goonie boxes underneath the table. Yeah, DX. There's a Marauder. Swan 500.
Beautiful on the front panel.
Oh my God.
You look in, there's no dirt or...
DX 100.
I bought it in the state auction.
A couple of shortwaves. Looks like maybe Helicrafters. 2 Helicrafters. National. And the Godset receiver.
Do I buy another old
With a B
radio,
on
or
it.
do I buy that old that doesn't have flex radio? Is everybody on AM going to flex now?
Beautiful. Goodie boxes. Yeah. And again, there's Larry. Look at him. He's looking. He's diving deep into those Goonie boxes.
You've seen the clients. And I mean, don't get me wrong. I mean, a client, you're
Oh, Johnson Viking Matchbox. Only about 50 times nicer looking than the one I have at home.
Depends what model you're
It's
getting.
$60 too.
You're right.
That's a great deal for somebody who wants to run balanced line right out of there. Link couple tuner. Very, very nice.
75. Or maybe,
And what's this guy? This guy, is this a 440? Yes. Wow. Cool.
Fixed radios as well as an old Grundig that, no, I used to.
Oh, helicopter on the back of the truck. I see 746.
Displays. After so many years, they just go. So he leaves them
Pro
on
2,
all the time.
756. Heath Kit antenna tuner. Cool. This is the kind of stuff I really enjoy. Oh look, here we have a MFJ differential type tuner. Let's take a look inside. Wow, another DX100. Oops. And an NC300, $75 or best offer. And who hasn't had a Dentron Super Tuner? Wow, more older stock. 75 series something or other here. Let's see. What is it? 75A3 receiver. Okay, back again. Okay, back again. It's like a Courier Royale 11-meter rig. Some sort of military radio there. Some other sort of military radio. And a Heath Kit antenna coupler. Ah, the Simpson 260. Man, who hasn't had one of those? Boy, not as nice shape as that.
Yeah.
That's beautiful.
This is the shock case that
Wow.
it wasn't sold with it. It was, you had to pay extra for it.
That's beautiful.
Yeah, and you get a junker with this too, in case you blow something out. you get I got a junker that goes with it.
Yep. Beautiful.
Yeah, look at this. Look at this.
Oh, covered. Roll top desk cover.
Yeah.
Beautiful. Man, that's nice. There's some interesting speakers. Bozak.
Bozak's manufactured in Norwalk. Yeah, and they're good.
Yep. There's a bunch of unknown radios, at least unknown to me. Maybe 11 meters on some of them. Oh, Kenwood Twins or best offer. $200 or best offer, and it works. Look at that.
So you don't have any.
Custom special.
No, I mean if you wanted to like.
Another Heathkit DX45, or excuse me, 35 for 45 bucks. Decent shape.
What are you talking about, man?
A Globe Scout. Heard that on 75 meters AM, but I'm not sure what it is. Wow. Another Collins radio.
That was 25.
Or Collins lookalike. This one's made by
I'm working on.
Signal Corps, Army Signal Corps.
I'm up at Boxborough last year.
Some nice big, what are they? 10 microfarad at 2500. Don't really want to grab a hold of those things when they're charged. TR4 and RV4 remote VFO. Beautiful. A 6 and 10 linear amplifier night kit. I wonder if that uses sweep tubes. Wow, a lot of stuff here today. Let's take a walk over there and see what that gentleman has.
David Wolf for $300-400.
Most of this stuff
Here's a 2-meter filter.
I can't sell the Rangers on today. They're just too heavy.
Yeah.
And they would be.
I think I might just get that.
You know they'd show up and.
Okay, and now the proud owner of this 2-meter bandpass filter, and take it home and sweep it and see what happens. What else? What else? A block of time.
That's because they are crutches. The AA1XP J-Pole 2-meter, and they work fantastic.
Yeah, I've had
This gentleman has a ton of speakers here.
He hears stuff and hits stuff he never heard before, and the guy sits in a hole.
I don't remember what
Wasn't this
magazine, but
interesting?
he did one with the.
J-poles made from crutches.
No kidding.
Look at that.
No, this is just
There's a tuning there.
But it's here.
Very interesting. I think this is Mark AA1XP.
Is that because you know the gentleman?
Some more microphones. Test speakers. And we are soldering iron, Kenwood. Zenith Transoceanic for you 1V4, 5R4 low voltage tube movers. Had one of those. That was one of my first radios. The series resistor from the line was broken. in 1971. High school teacher fixed it for me, and I think that's what cinched my interest in electronics ever since. Let's move along.
I haven't, like, look, the lineup looks really early. The coils look like they're, first generation.
Looks like a DX100 sideband adapter.
Oh, extra switch.
Oh, that's cool.
It's funny,
That's cool.
The last SW3s that I bought.
Wow, a lot of vintage equipment here.
Everybody in the theater.
A lot of vintage equipment.
Right? Like I was at a
Here's something I've never seen before, a Mosley
This guy
CM1.
was dying to like buy an SW3 like 25 years ago, but he didn't know where to look, and he had seen
Johnson Viking. Let's see what he wants for the Viking.
getting out these like mimeographed
425.
photocopies.
Yeah,
Just
little
like
bit
clip,
steep,
he
little
clipped
steep.
shots from like
But
magazines.
this might be
But, like,
negotiable.
he says, he hands one to me.
Here's something I never saw
Oh yeah, I know
before. A
what this is.
Lysco
You're like the first person I've ever handed one of these to who knows what this
Transmaster.
is, right? So I kept it, had his number on it, and like about 6 weeks later, a buddy of mine calls me up, and he's breaking up an estate. There's like 2 SW3s, like a big number of bills, and we didn't even know exactly what it was. But it was funny because he
a bunch of Heathkit equipment.
so I actually did the deal with him like 1 in the morning.
And 500,000 rubber duck antennas.
Drove up because that's what he was around.
And some sort of
He says,
L&B.
yeah, I'm interested. He goes, well, how much?
Microwave receiver, LNA, LNB.
I can't hear you.
Records, bins full of who knows what. Oh, no Heathkit key antenna.
What about 8 years ago? 8, 9 years ago? I got that from you? Yeah.
Oh, look at this. I'll have to ask Bob at work about these. Viking Mobile. Viking Mobile, what's that, the VFO? Hey, that's something.
3 of us.
Another low pass. Yep, low pass filter. Drake.
My block lights closed the door. Yeah, that one got sold. That's no problems. It stops, the door back. Close the door, there's no windows or lights inside a fan.
Now this is a cool arrangement. Got the Halicrafters and the Sky Buddy. Look at all these soldiers sitting on top. Bless you.
Oh my God.
Allied, another Halicrafters. Wrench collection. Hemostats. Interesting pair of binoculars without prisms. It's interesting. I haven't seen those around.
I'm gonna play with repeaters and like maybe
Gear drive for some kind of gigantic drill.
yeah. And I know what my side of this site.
Is that a rebuild, remake? New York to Paris, 2-valve radio, patent pending. Oh my God, the old SAM meter we used to use at work. Signal analysis. Boy, I'd like to find a few more bandpass or tunable bandpass filters. It's a 1 kilowatt Heathkit Warrior linear amplifier.
Wife was right when they said that they'll let anybody in here.
What's going on?
Only a couple of things, $2 worth of expenditure, so.
There you go.
Engine analyzer, sling box. You know, that's the thing about these ham radio flea markets. You just don't know what you're going to find. grinding wheel, fender amplifier, sander, portable battery jumper. There's Steve, K1IIG. MOTS 520.
No, you see, I got this monitor.
Yeah.
My name is.
Oop,
People call me Gold.
the 141T.
So for $10 it would have been worth
Look
it,
at
right?
that.
And how I got that was,
That's
I
amazing.
went and I got a name badge.
Here's all the analyzer modules.
Right down where you want to name it.
Doesn't scan, no scan.
Put the lowercase part in it, but it didn't quite get
Radio Shack 1000 channel scan.
part of the fee.
Bunch of vintage. Take me, take me! I'm free, take me! Wow, the portable phonola. You guys are gonna laugh at me because I'm not familiar with a lot of this stuff. Now there is a nice antenna.
Good morning.
Good morning. Just trying to show the antenna. I didn't want to.
Oh, let me get out of
Wow. That's got to have the biggest coil that I've seen. Beautiful.
There you go.
Thank you. Boy, is that beautiful.
My
Well,
husband likes it.
yeah, yeah. I guess it's in the eye of the beholder, isn't it?
That's okay. Keeps him happy.
Wow. And it's self-supporting too. That's the interesting part. Get in a little closer. Beautiful.
It's commercially made. Yeah.
I got to get a picture of
At
the
the toad,
toad.
yeah.
1930 nightly 160. There's quite a few different characters on 1930, isn't
Yes,
there?
there is.
Okay, back at the Toad Harbor Net table. Look at the Sky Buddy.
That makes good sense too. That makes good sense too.
We want our enemies to live long and suffer.
Hey, Ron.
What's up? Paul, what
You're
are you
on
doing
video.
there?
Okay, let me, yeah, I'll get it back to you.
Try to
Come on, guys.
blackmail
This
us.
is
guy's trying to
Ron,
blackmail us.
WZ1F.
He's saying that
the sound of the
unless I give him
southern
$100,
shore.
he's gonna put it on Facebook.
Yeah, there's a guy who did a good job.
Okay.
My neighbor.
Now this is nice.
LZ.
Oh, really?
He's the only other active Flint ham
Besides you.
besides me.
Beautiful. Look at that with the meter and everything.
Huh.
So he's gone. Now there's hardly anyone on here except for me.
Gotta be able to melt it.
Yeah, yeah. Depending on what the environment is going to be, sometimes you want to post-process by painting it to provide a layer on the outside for UV exposure. That's usually the most I do. And the stuff's pretty cool.
What's you making now?
A vase. It's doing a spiral vase.
And it's going to build it up.
Yep. Yeah. So the spiral vase I'm doing is a single. Yeah. So the spiral vase I'm doing is a single. It's a single 0.6 millimeter wide or 1 millimeter wide. So it'll just go all the way up. And once it starts, it'll just keep going on the spiral. Yeah. Yeah. Yep. That's pretty representative. a two.
So, flea market's too big, can't get around, tired? Hop aboard this electric scooter. Hello everyone, this is Paul, W1VLF. This is a project that I worked on a couple of years ago. It's a ruggedized version of a 2-meter ground plane designed to mount very quickly on top of a 1 1/4 inch standard television mast. We've all seen the PL-259, or actually SO-234 ground plane that can be made from a couple of pieces of copper wire and a chassis connector. This antenna was designed to be portable, rugged, and well, you guys take a look at it. Tell me what you think. Here's a couple possible uses for the antenna. Some objectives that I set for myself when building this antenna it had to be very rugged, so if you tipped it over or it fell off the table or something happened, it wouldn't break apart. Easy and quick to assemble. A minimal amount of tools for assembling the antenna. For a non-permanent or temporary deployment, you don't need any tools. But if you're going to mount it somewhere permanently, a 7/16 wrench and a small Allen key. Wanted it to be waterproof and also have a very small footprint when disassembled. You'll see that in one of the pictures as we move forward. Here's the antenna mounted in my backyard on a 1 1/4 inch aluminum mast. You can see that the radials slope down at about 160-degree angle, and that was empirically arrived upon by many prototypes until this finished product came along. This is not going to be a actual build. This is not going to be a actual build or how to build this antenna, because it starts off with a 2 1/8 inch diameter slug of aluminum, and it needs to be machined using a lathe, a milling machine, and a tilting rotary table. More that this video is just to show you what could be accomplished and maybe give somebody an idea of how they want to build something on their own. Here's the central hub or slug of the antenna, a 2 1/8 inch piece of aluminum cut, faced off, drilled, bored, and finally the UHF barrel inserted. We'll take a closer look at each one of these pieces later in the video. The raw slug of 2 1/8 inch aluminum for the main body of the antenna. The same slug after it's been machined flat and prepared for the next set of operations. The hub has now been drilled. The set screws for permanent installation have been drilled and tapped and installed, and there's also one set screw off to the side on the left-hand side of the picture that will hold that UHF barrel in place. You're going to see that the set screws that hold the slug onto the mast are not stainless, but in the final version they would be. This photo shows the long UHF barrel in place. The hole in the center is such that it's almost a press fit. There is epoxy applied to the threads in the middle so that it can press fit in and make a watertight seal. And you can also see on the side the hole for the set screw to firmly make a very positive contact to that UHF barrel. A better view of the long UHF barrel, the nuts that hold it in the center of the hub. And here you can see the threaded elements, the 1/4 inch 6061 T6 aluminum elements, the holes that each one will thread into. Very strong setup. The underside of the hub showing the UHF barrel and the 6 1/4 20 tapped holes angled at 120 degrees for the elements, the aluminum elements to connect to. I tried as many as 10 elements and it didn't seem to change the SWR on the antenna. 6 ended up being a good number and worked out well. Here's an example of the aluminum threaded with the stainless steel locking washer. These elements simply hand twisted into the hub and fit in there pretty snugly. If you were going to use this in a permanent installation, you'd of course torque those quarter 20 7/16 nuts down permanently. Here's a view of the PL259 and the aluminum center radiator. You could put a little bit of compound on the threads or tape it up permanently to make it completely waterproof, but it unscrews. It has a Delrin insulator in the very center of it, which I don't have any real good close-ups of, but that was also machined on the lathe. A close-up of the hub with the radiator attached, the elements screwed in and mounted on a piece of 1.25" aluminum pipe. Here is a photo of the antenna as you would use it indoors. The coax cable would go up through the pipe and screw onto the inside of the hub, and you could just leave it mounted right there on your desk. Or wherever. Worked out very well like that. It's quite stable. All the elements are very equal in length, so it doesn't tilt or anything. If you're going to use it inside and it's below your eye level, I would be very, very careful about that so you don't poke something out. Hey guys, welcome back to the lab. I'm Paul, W1VLF. So, I have this mystery box in front of me. It was given to me by my son and my daughter-in-law. I recently moved into a new home, and in the basement, this is an older home, and in the basement they found this box. And knowing that I have an interest in electronics, they said, "Hey Dad, what the heck is this thing?" So, what the heck is this thing? Let's take a closer look inside and try and figure it out. Okay, so obviously it's homemade in a wooden container. And an on-off pull chain type arrangement. It's shielded with what looks like a very, very old window screen. Let's take the cover off. Well, I guess that's seen better days, but this is quite an old device. Well, that looks like a transformer from an oil burner. And it runs to what looks like a mason jar that's got brass screening. Wow, there's a great solder job for you. There's a great solder job for you right there. Brass screening on the outside, brass screening on the inside, and I don't know, maybe it's a, let's see, what does that say? It says 1 3/4 cups, so maybe it's not a mason jar, but it's some sort of jar. It's held in place by what looks like 4 leather straps, and the high voltage from the transformer comes out, goes to the inner plate. The ground part of the transformer, or the other side of the transformer, goes to the outer plate. Give you a chance to think about what that might be, and then we'll fire it up here in a couple of seconds. Okay, I'm back. Got a power cord on it. And it looks like it wouldn't hurt to plug it in, so I'm going to do that, and let's take a listen. Okay, obviously I'm nowhere near this thing. On the other side of the room with a switch, I'm going to fire it up. 3, 2, 1. Whoa, listen to that. Ooh. Yep, it's an old-fashioned ozone maker. Oh my God, what a smell. Ooh, it's been about 10 seconds and the smell of ozone is absolutely potent here. I better shut it off. Whew. Here's the cover that was supposed to keep, with that high voltage, keep people from annihilating myself. Wow, you can't imagine what that smells like. Whew. Let's see if it works with the cover on, and then we'll get a close-up. Maybe we can see the corona arcing between those terminals. Let's try it again. Not sure I would stick my hand anywhere near that, even though it has the screening on it. Okay, I'm going to shut it off, take the cover off, and zoom in on the part that's arcing. See if we can see what, and I'll even shut the lights off and see what happens. Be back in a second. Okay, now we're zoomed in on the business end here, the jar. Going to walk over to the wall switch and turn it back on. If we can't see any arcing, then I'll shut the lights off. Any arcing, then I'll shut the lights off and see what happens. Here goes. I don't know if the camera's picking that up, but I can see a slight glow. I hope you can hear that because it's a very eerie sound. Well, let me shut the light off and see what happens. Phew, man, what a stink. Well, I can't see it glowing really that well. I'm going to take the jar out and we'll get a closer look. Oh, I can hardly even see it. No, nothing. Actually, wow, I really wish I could figure out where that arcing was coming from. Oh! Let me look again. No, it's not really visible. Okay, it's perfectly dark in the room here now, and I can't see anything, but the camera seems to pick it up, so take a look. Watch this. It's just going to look like a tiny fringe around the outside of the jar. Here goes. 3, 2, 1. So I think I'm seeing a purple fringe, although my eyes can't see it. Oh, it seems to be changing as we the longer it's on. I'm going to shut it off again, and you guys see if you think that drops off at the same time. Here goes. 3, 2, 1. I couldn't see it, so did it go away? Looks like it did. All right, so I'm going to turn the lights on now and show you exactly where we're zoomed into. I'm kind of seeing this myself. Okay, that's the all those sharp edges, all those little radiators there. Interesting. The smell in here is unbelievable. I feel like I'm going to pass out. So let me shut this off, clean up the air in here a little bit, and I'll be back. Okay, we're back. Man, I really had to open the windows to get rid of that ozone. I can't imagine somebody thought this was a really great idea to have one of these things running in their basement. I'm going to put the lid on. Now, note where that is and note where the lid is. So, knowing that there's very high voltage in there, do you think that affords you a serious measure of protection? I don't. Anyway, thanks again to Steve and Nicole for finding this contraption and bringing it to my attention and letting us have a little bit of fun with it. A quick thank you to my friend Gary, who without him this video would not have been possible, because he's the one who actually foraged through the deep dark corners of the basement and brought this thing to the surface. Thanks again, Gary. Hi guys, my name is Paul and welcome back to the W1VLF lab. What is this thing? It looks like a milk crate. Well, it is a milk crate. It's called a pile, a portable induction launching equipment. What the hell is that? Well, basically inside here there's a large quantity of electrolytic capacitors which I charge, and they dump all their current through this relay into this flat pancake coil here. And this is the projectile. First of all, don't screw around with stuff like this. Don't say I said to. Just don't mess with it. There's 1500 volts at many thousands of microfarads available inside here, which is a lot of current capability. Just don't do it. Let me do it. I've already had my kids. Something happens, oh well. So anyway, what does it do? Well, when you dump a huge amount of current into this flat pancake coil, and I'm going to show you this all up close later. Well, let me just say one more thing. Like everything else, in the W1VLF shop lab here, it is a piece of crap. Okay? I really put this together quickly about 15 years ago, and there's some stories I could tell you about. What does it do? When you dump this extreme amount of current into this coil, this projectile will go develop eddy currents, and a reverse magnetic field from what's in this coil will be generated. The exact same magnetic field will be generated from this coil that's in here, and what will happen is this will fly up into the ceiling. So I'm going to show you, I'm going to charge it to, let's say, 100 volts, and you're going to see how non-spectacular that is. A little button over here. I have a meter here that you guys can't see, but I can. And like I said, here's how I'm going to launch it. Thing's a real piece of crap. So here we go. Also note, one hand in the pocket whenever you're playing with anything high voltage. That way there, the worst thing that can happen is you get it across your arm, but you can't get it across your chest should something really bad happen. So here goes. I'm going to charge up to 100 volts and you watch the disc fly up. All right, that's about 200, so we're going to wait for it to settle back a little bit. There's bleeders on every one of the capacitors, so it bleeds down very, very quickly. No, not quickly enough, evidently. We're down to about 150 volts. Now, I guess we're going to fire it off at about 150. Here goes. This won't be that spectacular. There it is. Alright, so we're going to reload. Going to recharge. By the way, almost all the large capacitor bank is discharged after one shot. Here we go. We're going to go to 200 volts. Alright, we're at 225 volts. It's going to be a little bit more violent this time. Here we go. 3, 2, 1. Jesus. Alright, time to put the protection in place, and I will be right back. Alright, so we're back. And you're saying, I know what you're saying. You're saying, W1VLF, what the heck is it with the ear suppression, the noise suppression? Well, it's pretty damn loud. I'm going to go to 400 volts this time. The blow shield is in place. It's just a piece of cardboard, but I think you'll get the idea. There's the puck. We insert it into the coil. Stand to the side. Keep one hand in your pocket when you're dealing with high voltage. That's 100 and charging. 200. 340. Okay, here goes. Where's my wire? Here we go, 400 volts. Jesus Christ. Uh-oh, that wasn't good. Well, that ceiling needs to be fixed. All right. Okay, we're back again with a new and improved heavier duty cardboard blow shield. I better put something over here just in case. Alright, so the puck is a 3-inch diameter piece of 6061 T6 aluminum, 1/4 inch in diameter. I'm going to load it into the coil. Actually, I'm going to bring this back a little bit more here. Okay. So here we go. This is going to be a 500 volt shot, significantly more power than the last one, and hope nothing goes wrong. Alright, 250, 4 1/4. Okay, it's 550 volts. Whoop, it's coming down pretty quick. It's 530. Here we go. Oh, Jesus, that's violent. Jesus. So, I think that's enough. Coil's a little bit warm after just 3 shots. Okay, I'm back. So here's what I was looking at. Here's the coil. It's made out of flat wire, 1/4 inch by 1/8 inch thick flat wire. Just about 3 inches in diameter. I don't know, maybe 30 turns. It has a resistance of 0.013 ohms, so 13 milliohms, and an inductance of about 13 microhenries. You can see it's big, heavy, flat wire. By the way, this is going to be a multi-part series. Tonight we're just going to show a few shots, take a look at the outside of it, and then I'm going to tear it down. I'll also put in a few diagrams, probably in the next video, to show you exactly what's going on here. But this is the top. This is the transformer that charges up the big caps that are located in the bottom of this milk crate. It's a small transformer to charge up this capacitor, which dumps into this contactor over here. And that's what fires off the high voltage into this coil. So we went to 500 volts, and the capacitors are rated, the series parallel capacitance in here is rated for about 1,000 volts. So we were maybe 50% at best. So I'll pop the cover off here now and let you see inside. Okay, so here's the capacitors. 2400 microfarads each, 2 in series, that's 1200 microfarads times 5 in parallel. That's 6,000 microfarads at about 500 volts. We only went to 400. Each one in series, so really the thing can go up to about 1,000 volts. A couple of big rectifiers. Like I said, what a piece of crap, huh? I mean, I really threw this thing together. Look at that. A couple of large rectifiers. Charge here. Let me show you some of the other components real quick, and then I'm going to end this one because the furnace is running. There's the coil. Pancake made out of 1/4 inch by 1/8 inch, wound on a lathe. And there's the giant contactor. Slams shut pretty quickly. So anyway, that's going to be it for this episode 1. If you're interested in seeing me rebuild this and trying to make it into something that looks a little bit nicer and is a little safer, and eventually getting it outside and launching some golf balls with it. Golf balls? You didn't say anything about golf balls. Check out the pictures that accompany this video and you'll see what I mean. This is W1VLF signing off, 73. And remember, I'm good in the handbook. Hey folks, Paul, W1VLF here. Tonight we're going to be testing some loop antennas that I made, receiving loops. Some were for the broadcast band, some were for LF, some were air core, some were ferrite. And I'm just going to show how you can tell if your loop is resonant, whether you're in the ballpark of what you thought you were winding, and ways to fix them if it's too high in frequency or too low. Stay tuned. Hey everybody, my name is Paul. Welcome to the W1VLF lab. Got an interesting video for you tonight. Over the years I've made a lot of loops. Here's a couple. Enameled wire loops, Litz wire, ferrite core loops for long wave frequencies. Oops. Air core. Just literally 50, maybe more loops of different sizes and dimensions. So here's the question. There's plenty of videos on YouTube on how to build these loops. And people say to me quite often, geez, I'd like to build a loop like I see on videos on YouTube, but I don't have exactly the same materials, and I don't know exactly how many turns to put on it. And so tonight we're going to take a look at one of these loops. Actually, we're going to take a look at a whole bunch of them, different kinds, and we're going to find out what the resonant frequency of this loop is. And this loop, and this is a coil, but we're still going to find out what the resonant frequency is. And it's very simple. You just need two things: oscilloscope and an RF generator. I'm going to set those up here on the bench and show you how this can be done. Oh, and a clip lead. Clip lead's very important. So I'm going to set this up on the bench. I'll be back in a few minutes. For you it'll only be about maybe a couple of seconds. And we'll find out what the resonant frequency of this loop is. If it's too high, then we can take a turn, we can add a couple of turns. If it's too low, we can take turns off. So you don't have to be afraid that, geez, I don't know where this loop is. Will it tune? What frequency is it on? Build the loop with the materials that you have. You'll see how non-critical this is. Build it with the materials that you have, and then go from there to tune it properly to get it into the frequency range that you want. This might end up being two parts, but anyway, I'm going to set up and I'll be back. Okay, I'm back. Well, at least part of me's back. So, what do we have here? We have a RF generator here. In this case, it's an old HP function generator. I think it's good to 50 megahertz. Yeah, 50 megahertz. And an old oscilloscope. Now, if you're an experimenter, there's no reason in the world not to have at least these two items on your test bench, your bench. 25 bucks, 25 bucks at flea markets. So it's not a bunch of exotic test equipment. It's just run-of-the-mill stuff that anybody can acquire rather cheaply. Okay, so right now I just have the RF generator connected directly to the scope probe, and you can see there's a display on the screen. Okay. All right. So there's a nice RF display. I think we're at 2.5 or 2.78 megahertz right now. So the first coil that we're going to test, or not coil, but antenna. This is a roughly tuned, somewhere in the middle of the broadcast band. This was something that I had built an awful long time ago. It's Litz wire. It's mounted on an 8-inch piece of PVC. Cut it off with a table saw, and then smoothed it out so that, so it looked decent, not like the rest of the stuff around the lab here. And then of course I just poke a couple little holes right here, right there, that one, and that's where I bring the wires out. So I don't remember the inductance of this. I don't even remember where I tuned it, where I made it for, but it's because it was probably 10 years ago. So first thing we're going to do is we're going to connect this to the oscilloscope. Okay, it's not critical which side is which. So we're going to put the ground lead here and the actual scope input side there, and adjust the gain. Nothing. So now we take the RF generator. Let's see, can you see the loop? Let me move it around so you can see the loop better. You can see both of those connections. Yeah. So the connections, no you can't. Connections are here. And here is the RF generator test, the output from the RF generator right here. So here's where the clip lead comes in. You simply take the output, this is the ground lead, this is the hot lead.